Good morning, everyone. This is Richard Moore from Red Wing Software, and today I'd like to review a set of slides that was originally presented at the 2017 mid-year meeting of the AgGateway Standards Organization. The title of the presentation was Implementing ADAPT with version 1.1.010. Before we get started, the fact that I'm mentioning a version is probably of significance. Version 1.1 would indicate that, in fact, the ADAPT framework is fairly new in that it's only been available for about a year as of June 2017. But that doesn't mean that it's not available and ready for production. In fact, several companies, large companies, have been using the ADAPT framework successfully within their organization for more than a year. These would include people like John Deere. The second thing about mentioning a version is that you would expect it to evolve, and that certainly is the case for ADAPT. ADAPT is at the beginning of its life cycle, but everyone expects that this technology is going to grow and evolve and become even more robust as we go forward. So the question for today is where to begin if I'm going to look at implementing ADAPT within an application. The first thing to note is that there are several resources that are freely available, and most of these can be found through links on the adaptframework.org. That's an important URL to take note of if you are looking at implementing the ADAPT, because all of the resources are centrally located there and can be achieved through links. You can find things from that website, such as an overview of the ADAPT framework and the models associated with it. You can see what we're calling MVP, or minimum viable product application notes, that discuss real-life scenarios where ADAPT can be used to solve real business problems. You can also find a link to a GitHub repository where there is sample code, as well as several of the pieces of the ADAPT framework that you'll need to begin the implementation. The ADAPT data model itself, and then plugins. We're going to talk a little bit more about plugins later on. The second thing that I'd like to review today is some key concepts for successfully implementing the application data model. We'd like to talk about the organization of that model. We'd like to discuss the notion of referencing data versus containing data within the model. Certainly want to talk about compound identifiers. It's a key part of the application data model. And then we'd like to take just a little bit to say, what does it take to actually begin building your own application? So the place where I'd like to start here next is looking at these application notes, these real-life examples of how ADAPT might be used to solve business problems. I put together a chart of where we are at this point in time, June 2017. At this moment, we have, as you can see in the left-hand column, several application notes that have been started and are at some point of their development. We also have 3 that have been finished and published. When I say published, I mean that they are now available on that application or adaptframework.org website. So let's take a look at one of those. If I go out to the adaptframework.org website, you notice up at the top there's a menu that gives me access to links to the grower, farm, field, the field boundary, and the identification. As more of these application notes are published, this is where you'll also find references to those. Let's take a look at the grower, farm, field. This format that you see is one that will be used by all of the various application data notes. So once you're familiar with how to decipher one of these, you'll be familiar with the others as well. We start with a description and some assumptions about this particular application note, and then we go through a series of one or more user stories. In this case, a user story where we are moving data between two FMS applications. Another one where we're looking at active crop zones, etc. We'll also try to include some sample code describing the implementation of this particular application note, and also try to give some other reference material that would help you in the understanding and implementation of ADAPT in this particular use case. So those are the application data notes. And the one thing that you'll quickly notice when you begin to go over these various application notes is that ADAPT is all about sharing data. Data can be shared between usually one FMIS and another MICS. FMIS, you'll see that acronym all over, is a Farm Management Information System. Typically, that's the application that's available at your desktop in the office and helps you understand, analyze, plan, etc. information related to your production. And then an MICS is the acronym used to describe a mobile information control system. So in this case, if we're moving data between an FMIS and an MICS, we're probably preparing that MICS to go out and do some particular field operation. Likewise, I could be looking at moving data from an MICS back to an FMIS. So in other words, I've done that particular task out in the field, and now I want to take the data that's been collected and move it back into my office application. You can also look at ADAPT in ways to move information from one FMIS to another. So for instance, you've gone out, you've done the task, you've gathered the information, you've brought it back into your FMIS, and now you'd like to share that information with your crop consultant. So let's take a look at what I'm talking about. If I have an FMIS that's operating in my farm office, it has some sort of data storage that it uses and references so that I can keep track of the information and make use of it, understand it, analyze it, etc. What I want to do, though, is to share that information and set up my MCIS to go out and begin to be ready to perform that task that I'm going to do in the field. So what happens is my FMIS application uses what we're calling a plugin to communicate and build up data in the application data model from the FMIS's own data store. The next thing that happens is I go out to the MICS compatible plugin and say, read this data that I've just prepared in the application data model and move that into the proprietary data storage for that particular controller. So the application data model is nothing more than a transport vehicle to get the data from one application into a format that another application can read and understand and then use in its own proprietary manner. Likewise, when I'm ready to move that to my crop consultant, I can take the data out of my data storage, populate the application data model, send that to my crop consultant, whose own application can read that data and put it into its own data storage. So again, the application data model is there as a temporary transport, not a long-term storage solution, but a temporary transport to move that data between two different applications. Let's take a look at some key concepts that are used within ADAPT. First of all, what does this data model look like? And then talk about how some of the specifics of that data actually work. So if we're looking at the application data model to start, you'll notice that it's really divided into two separate categories. One is called a catalog. The catalog identifies various pieces of information that change relatively infrequently, but are always used to identify certain pieces of information, whether that's a grower, a farm, a field, a product, a crop zone, etc. It's the parts of the data that exist within your operation, but really are there so that we can make sense of the information that we're gathering in a certain period of time. That time-sensitive information is where our documents go. They're the results of what we're doing in the activities. So for instance, I could have a document that is a work order identifying what tasks I want to perform when I get out into the field. It may be a prescription, or it may be something more high level than that. The work records, on the other hand, record what actually took place as I was in the field. So in this case, I might have the results of spraying chemicals, of planting seed, or of combining the grain in the fall. The logged data gives me that spatial representation of that data that's been recorded in the field. We also have summary data so that we don't have to look at it just in a spatial orientation, but we can look at the summary values as well. The documents are the activity information that result from me actually doing something and wanting to record that information in my cropping application. Next, I'd like to talk about data that is referenced within the model, as opposed to data that's contained within a model. If I look at the grower farm field tree, you'll notice that a field contains this property called a farm ID. The farm ID points back to another record in the application data model that describes that particular farm. It gives me a name or description. It also points to a grower. The grower ID points to this record that says if I want to know something about the grower, I can look at that grower record and see that I have properties like name and contact info, etc. But a field doesn't need to contain the name of the farm and all of the farm description. And a farm doesn't need to contain the name of a grower and all of the descriptive information about a grower. It can simply reference that grower with a grower ID. Taking a look at the boundaries, a similar sort of thing occurs. This one gets a little more complicated in that if you follow this, a field boundary references a field by the use of this field ID, but each field also has a given boundary that at that moment in time describes the active field boundary. The fact that the field boundary isn't contained within a field should give you a hint that says we anticipate that active boundary could change from year to year. There's nothing saying that over a period of time, a wet hole in the corner or some pasture in the other side of the field couldn't be turned into tillable ground, in which case the active boundary is going to change. Being able to reference that says that I can now track a boundary that was in place during this cropping season and also know that during another cropping season, there was another active boundary in place. It's not something that has to change the definition of this field because that information has been referenced. On the other hand, if I look at something like a crop zone, part of the definition of the crop zone is this bounding region, the polygon that describes the orientation of the area that was actually part of that planting. That bounding region is contained within a crop zone, meaning that if that boundary were to change, it also changes the definition of the crop zone. So in this case, the field boundary, if you will, the bounding region, is not a referenced piece of information, but actually contained information within the crop zone. The next thing that I'd like to take a look at is the compound identifier. We've been talking about these field IDs and grower IDs and farm IDs, and et cetera. It's important to note that each of those are actually compound identifiers. And within the ADAPT model, this is a very key concept. Every compound identifier starts with a reference ID. That's a value that is used within the application data model to uniquely identify and reference any other object within the model. But you have to understand its value is only valid within the model that it appears. If that same information, a field, a grower, a farm, a crop zone, etc., is used in another application data model, it will likely have a different reference ID. But the reference ID within the application data model can be used to associate it with some other piece of information. Let me show you an example to help that out with that. If I have this crop zone, the ID within the crop zone, the property ID, is really a compound identifier. And as such, it therefore has a reference ID and then this other property, the unique IDs that we're going to talk about in just a second. If I look at the field ID within the crop zone, that field ID is an integer property whose value points to another record whose field ID, reference ID, points back and has the same value as that integer. So in this case, if the reference ID of this field record equals 122, and the integer value of this field ID is also 122, then it's easy to see that this crop zone is actually referencing this field record. Let's go back now and take a look at the second part of the compound identifier, the unique IDs. This is a list or collection of unique IDs from various other applications. So what we want to do is to say my FMIS application understands this field, as long as I'm talking about fields, as this particular value. This is its unique identification, and wherever that's used, it always points to this particular field. But over here in another application that's also using this same ADAPT data model to move data around, it has some other way of identifying that same exact information about that same exact field, but using some other identification system. The ADAPT data model allows for all of this and will keep that information within the ADAPT data model so all of the applications can continue to reference their own IDs and make sense of that data. The way they do that is through a series of properties within that unique ID class that this is a collection of. So the unique IDs is a collection of unique ID classes. each one of these contains a string representation of that unique identifier from that system. They also record the type of value that is actually being represented in that ID. So my application could say that I use long integers to describe my unique IDs. And so while this ID is represented as a string within my system, I treat it as a long integer. The unique ID class also identifies a source so that we can uniquely say this ID comes from this particular application. And that source has a source type, could be a URL or GLN. Let's take a look at some examples of this. So let's go back to my field. And in this case, let's describe a field that I've got and call the Home 160. That field, notice, has a farm ID associated with it, 14, and its active boundary is described by the some active boundary reference ID of 158. If I look at the ID value, remember it's going to be a compound identifier, and so the ID for this field has a reference ID of 122. That value, remember, is only applicable in this particular adapt data model. If I look at this same Home 160 in another adapt data model, it will likely not have a 122. However, the unique ID collections will always be the same. So in the application, excuse me, in the application XYZ, the unique identifier is a long integer, and this particular value identifies that Home 160. In the second application, who also knows and understands this Home 160, they have a different unique identifying system, and they're using string values. In this case, the HM160 represents this Home 160, and that is referenced by the ABC Company application. So in this case, 122 is the reference ID that is going to change from instance to instance of an adapt data model, but these unique identifiers will always be constant for those various applications. So if I'm over here and I look at a crop zone that references field 122, what it's really doing is saying that here's the integer that equals the field ID reference ID of 122. So looking at these compound identifiers, there's really two critical concepts that we need to consider. First is the value of the reference ID will be different with each new instance of the application data model. Key concept to understand. Don't count on that value being the same. However, the collection of unique IDs will, as long as it's persisted, will continue to identify the values within the various applications that are referencing it. So those unique IDs need to be persisted. If you're getting an application data model coming into your FMIS application, you'll need to recognize that the contributors, the people who also understand that application data model, have supplied their own unique IDs in that data model. You need to hang on to those and persist those so that when you again push that information out into an application data model, you're also pushing out their identifiers as well. So please be kind and contribute and remember the unique IDs that have been given to you. So let's move on and talk about where to start building your own application. Well, the first question is, what are you building? A plugin or an application? My definition of a plugin is a piece of software that is designed to be used by external developers as opposed to you using it within your own application. It's designed to be used by external developers who will use it to consume or generate an application data model to perform some specific or proprietary transformation. Remember, we talked about the plugin that would take the adapt data model and convert it into the proprietary data store of a controller or a MICS out in the field. So the proprietary nature of that data means that it's difficult to let other people, either from a business standpoint or from a technical standpoint, it's difficult to let other people just directly consume it. However, the plugin understands both the application data model as well as the proprietary nature of that data store, and certainly could be used to translate that information from one system to another. But it's designed to be used by someone else who's going to actually do the work. An application, on the other hand, uses one or more existing plugins. So if I was building an application to take data out of my FMIS and put it directly into a controller, I could use those plugins and move that data from one system to the other. So the application is actually going to use the plugins, perform the data on one or more application data models according to some specific business design. As you begin building the applitions, whether they're plugins or whether they're applications, it's important to note that the ADAPT data model, the framework, supports the .NET framework. The application data model itself is described as a collection of C# classes. If you go out and you look at the information that is in the GitHub repository, that's exactly what you'll find, is that the data model is described in C# classes. The ADM plugin is also built in C#. Now, that doesn't mean that you have to use .NET in order to work with the ADAPT data model. It simply means that in its base form, that's the way the collection is described. But this could be just as easily put directly into a JSON format or something else. It doesn't necessarily have to reside in the C# classes. The other thing that was a real advantage, a nice piece of work by the technical team, is that they've made the ADAPT framework available in NuGet packages, so that as I begin to develop my application and would like to use ADAPT, I can simply go out and search for the AgGateway ADAPT, and I will find all of these packages that are available. So the application data model brings in just the data model itself. If I choose to use the ADM plugin, I will bring in not only the application data model, but the ADM plugin as well as some other referenced code. Makes it really easy to begin using the ADAPT framework within your application. The other thing that I would encourage you to do is to look at the sample applications. They really have helped quite a bit in terms of understanding how the model is used within a code application. The other thing I would encourage is to ask questions. On each one of those application data notes we looked at earlier, there is an email address. Please feel free to send your questions or comments to that email address. It is monitored. Somebody will get back to you. So Good luck in moving forward. I hope this has been helpful and hope to see you using the ADAPT framework in your application soon. Thank you very much.